Hello everyone, this is Anju Joshi, working as an assistant professor in the Department of Computer Science and Engineering from ABES Engineering College, is going to deliver a lecture on the topic of closure of attribute set. In the previous video lecture, I have discussed about the concept of function dependencies and the Armstrong rules related to function dependencies. So moving on today, I'm going to discuss about the concept of closure and some practice problems related to this topic. So let's get started. So before discussing the formal definition of closure, first we will understand the basic concept of closure and then we will jump into the formal definition. Okay. So let's start with this example. Let's suppose we are given a relation R that has three attributes A, B, C, and we have the following listed function dependency, that is from A to B and B to C. And if I ask you that if you have attribute A, what are the other attributes that you can determine from A? So clearly we can see here that from A we can determine B, from A we can determine B, and from B we can determine C. So this becomes case of transitivity. Transitivity that we have already discussed in the previous lecture. So we can say that from A we can determine C as well. So we can conclude that from A we can determine both B and C attributes. This is called as closure of attribute set. Attribute set. Okay. So here I'm going to use a notation A. That means I'm using plus and superscript. Since we are computing the closure of A, so we will write the closure of A as like this, A plus. So logically it means all the attributes that we can directly or indirectly determine from. So if we compute the closure of A, since the closure of A will contain A itself, and from A we can determine B, and from B we can determine C. So it's a case of, as I've already explained, it's a case of transitivity. So from A we can determine C as well. So the closure of A will contain three attributes. So through A we can determine three attributes, that is A, B, C. So this is what called as closure. So just have a look that here I'm computing the closure of a single attribute, but we can also compute the closure of more than one attribute as well. Okay. Now let's get back to the formal definition. So the formal definition also says that, let's suppose we have an attribute set A. So closure of an attribute set A can be defined as a set of all the attributes which can be functionally determined from it. Let's understand this definition again with an example. Here there is a relation R Okay, and this relation R consists of these many attributes A, B, C, D, E, F, and these are the listed. This is a relation R, and these are the listed function dependency. And if I ask you that you have to compute or calculate or find out the closure of D, then how will you do it? This is a notation that you have to use, okay, using plus in superscript. Now see, from this function dependency, we can see that from D we can determine AF. So since we are computing or we are finding the closure of D, so the D will contain itself, and from D we can determine A and F. So we will write A and F. Okay. Then C, from A we can determine B. So B will also be there in the closure of D. Okay. Now let's check the other function dependency that we can use. C to D, we cannot use C because it's not there in the closure. And what else? From A to C, from AC to F, we cannot use this as well. From E to C, so this also cannot be used. So we can see that the closure of D will contain four attributes T, A, B, and F. So we can conclude that through D, we can determine these many attributes. Okay. So this is a very basic concept. It's quite easy to understand. Now let's discuss some practice problem related to this closure concept. So the first problem says that given the following relation R, A, B, C, D, E, F, G, and we are also given the following function dependency from A to B, then from BC to DE, and AE, G to G. Okay, so we have to find out the closure of AC. So how can we do that? Since by the definition we see, the definition says that the closure of any particular attribute set can be defined as a set of attributes that can be functionally determined from it. Okay, so we have to calculate or find out the closure of AC. So it means that we have to find out all the attributes that can be directly or indirectly determined by both A and C. So let's check. Let's use this function dependency and find out the closure of AC. Okay. Since we are finding the closure of AC, so in the closure, we will have the AC, of course. Then see, from A, we can determine B. So we can write B here in the closure. Okay. And we can see from this function dependency, from BC, we can determine DE as well. We cannot use this function dependency because to use this function dependency, we require this. We don't have this here. So we can say that the closure of AC will contain A, B, C, D, E attribute. So we can conclude that through AC we can determine A, B, C, D, and E. Okay. Now let's check another example. Let's try another question. Okay. So this question says that, okay, this question is a bit different. The question asks, the question says that given the following relation R, A, B, C, D, E, F, G, H are the set of attributes that this relation contains, and we are given the following function dependencies, these many function dependencies. Okay. And the question says that we have to find out whether this function dependency is valid or not. Okay. So in this question, we do not have to find out the closure. Okay, directly it's not asking us to find out the closure. It's asking whether the given function dependency is correct or not. So to find out whether this function dependency, that is E, C, D to H, is valid or not. Is valid or not valid. So to find out that, what we can do, we can compute or we can find out the closure of BCD. If the closure of BCD will contain the attribute H, then we can definitely say that this function dependency is valid. Okay, so we already know that how to compute the closure, okay, by using the given function dependency. So since we are finding the closure of BCD, so it will contain BCD of course. Now let's check one by one. We can't use this function dependency, but we can use this CD to E. So from CD we can determine, okay, and from E we can determine C, which is already in the closure, need not to write it again. From D we can determine AEH. So we can, E is already here, so we can write here A and H. Now C, we need not to move further because here we just wanted to know whether this closure of BCD contains H or not. Since the closure of BCD contains H, closure of BCD contains H, right? So we can say that this dependency BCD to H is valid or okay. So all right. So in today's video lecture, I discussed about the concept of closure and what does it actually means, and we also solved some problems related to this concept. Okay. So in the upcoming video lecture, I'm going to discuss some furthermore topics on the subject DBMS. That's all from my side. Thank you.